Hey there, this is just a video of me making the answer key to the practice quiz I handed out. So, for the following quadratic function, sketch and state the domain, the range, and everything else. And of course we've got some space to work and then some space to graph. Okay, let's see. What does the equation tell us without moving anything around? First of all, they're messing with us, like there's more than one x or y intercepts. Ugh. That's just trolling. So the y-intercept is when x is 0, so that would be the 5, because if x is 0, then that's 0, and 5 is the answer. So the c value, when you're in standard form, is always the y-intercept. The direction of opening is downward, and I know that because the a value is -1. Okay, so that means the domain, this is the easiest half mark you're ever going to get from me, is all real numbers. And, okay, everything else I'm going to have to figure out a little bit. So, to find the vertex, remember we have a little formula for the x coordinate of the vertex. It's minus b over 2a, which is minus 4 over 2 times -1, because remember this is the b number, that's the a number right there. So that's going to be -4 over -2, which is 2. So that's the x coordinate of the vertex. The y coordinate of the vertex is, well, let's plug 2 into the formula. And that would be the negative of 2 squared, which is -4. -4 plus 8 is 4. 4 plus 5 is 9. So that means that my vertex is 2, 9. My axis of symmetry, therefore, is x equals 2. My x-intercepts happen when y is 0, so I'll show the work over here for that. The work would be 0 equals -x squared plus 4x plus 5. I think I'll factor out a -1 and then divide both sides of the equation by -1. So that'd be x squared minus 4x minus 5. Then I ask myself, I say, self, what two numbers times to make -5 and add to make -4? It's minus 5 and plus 1. So that means my x-intercepts are 5. That makes that one 0, and -1 makes the other bracket 0. Okay. Oh, I forgot about range. Well, if I know that I have a vertex that goes to 9 and it opens down, then 9 is my maximum. So that means that I start at -infinity and I go up to 9, solid bracket. Okay, I'm ready to graph this thing. So let's go to the vertex first, which is 2 over and 9 up, which is about there. And then my x-intercepts are -1 and 5. And that's really all I need. Oh, I might as well put the y-intercept on it. That's 5. That's good enough. That's all I need. So I'm going to curve that down, curve that way, and turn around and curve that way. And there we go. Good enough. Sketched. Next, number 2. Find the equation of the quadratic function whose vertex is 4, 3, and it passes through the point 3, 1. Okay, so that means y is equal to a times x minus h squared plus k is my vertex form without any numbers. I know that I can plug in the vertex of 4, 3. So that's x minus 4 squared plus 3. And I also know that it goes through the point 3, 1. So to find this a value, when y is 1, x is 3. So let's see, that's going to be 3 minus 4 is -1, but -1 squared is 1. I minus the 3 from both sides, and I divide both sides by 1, so a is -2. So it doesn't say that it wants this in standard form, so I'll just leave it in vertex form. My equation is minus 2x minus 4 squared plus 3. Okay. And for number 3, state the following. The vertex, okay, well the vertex is 4, -2. The x-intercept, that's going to take a little bit of work. So the x-intercept happens when y is 0. So when y is 0, I have to solve this thing for x. I'll start by adding 2 to both sides. I'll divide both sides by 2. Then I'll square root both sides, remembering that that means that the answer can be plus or minus. And then I'll move the 4 to the other side by adding 4 to both sides. So x would be 4 plus or minus 1. So x would actually be 3, or the other answer, so it would be 5 So that's my x-intercepts, vertex. The y-intercept, of course, happens when x is 0. So let's plug in a 0 for x. And that would be 2 times negative 4 squared minus 2. Negative 4 squared is 8. 2 times 8 is 16. So I've got 16 minus 2 is 14. And there we go. Got our x-intercepts, our y-intercepts, and our vertex. Next. All right. Once again, this is all basically the same thing, just kind of asked in a different looking way. So let's find our vertex. All right, well, if I'm going to find the vertex, I need to find the x-coordinate of the vertex using my formula minus b over 2a. So that would be negative of negative 5, which is 5, over 2 times 2. Ooh, this one's going to be a fraction. So that's 5/4. So that's my x-coordinate. My y-coordinate would be plug that into my equation, which is 2x squared minus 5x minus 3. So 2x squared minus 5x minus 3. Oh, goody, fraction work. So that's 2 times 25 over 16, which is 25 over 8, minus 25 over 4 minus 3. Okay, well, the common denominator here is going to be 8. So that's 25 minus 50 minus 24. With me so far? They didn't give me much room here. 25 minus 50 is negative 25. Negative 25 minus 24. 25 and 24 is negative 49/8. Okay, so that would be my vertex. So my vertex is, going back to the top here, 5/4 for x and negative 49/8 for y. My domain, negative infinity to infinity. My range, okay, this parabola opens upward because 2 is a positive, and if it opens upward, that's the smallest it can get. So that means I start at negative 49/8 and I go up to infinity. Okay, any questions about that so far? Like I can hear you're making questions anyway. Direction of opening, like we said already, is up, and we already know that if it opens up, it has a minimum, and that minimum is negative 49/8. And its equation of its axis of symmetry is x equals 5/4. So it always has to be the same as the vertex's x value. Okay, x-intercepts I'm going to have to work out. So x-intercepts are what happens when I take my equation and I set x to be, or sorry, set y to be 0, because 0 is for y where the x-intercepts are. So I'm going to factor this thing. I could do this by decomposition, but I can kind of see this one. 2 3s is 6, and 6 minus 1 is 5. So I just have to kind of organize it so that the 2 times is the negative 3 to make negative 6, and then plus 1. So there we go. So that means that I have 2 x-intercepts. I have x equals negative 1/2, and I have x is equal to 3. Cool. So back to there, negative 1/2 and 3. My y-intercept I can just read off of here. That's when x is 0, so that's just negative 3. I think I'm ready to graph. Okay, I'm going to have to estimate these fractions a little bit. So let's see. Let's do the y-intercept first. The y-intercept is negative 1, negative 2, negative 3. The vertex I'll do last. Actually, I think I'll do the x-intercepts first. One of them is 3, and the other one is negative 1/2, which is about there. And as you can see, this is going to do that. So now the vertex. The vertex is 1 and 1/4, right? 5/4, so 1 and a little bit, and then it goes down 49/8, which is about negative 6 and 1/8. So about a quarter, and then go to negative 6 and a little bit. So somewhere around there is going to be my curvy. And don't forget to put arrows at the end. They tell me I'm supposed to take off a half a mark if you forget to put arrows at the end. All right. Next, number 4. Ooh, working backwards. Start with a graph and tell me what kind of equation it is. Well, okay, let's see. We're going to have to make some assumptions here, and that is that these points actually go through the corners that they look like they go through. So this is 2, and that's 5, 6, 7, 8. So this is 2, 8. So there we go, back in vertex form. we know that y equals sum a times x minus 2 squared plus 8. Now, what is this a value? Is this a value 1 or 2? Well, here's what I know. I know a regular parabola, if a was 1, if this a was 1, then this would go 1 over and 1 up, 2 over and 1, 2, 3, 4 up. And it's not doing that. It's actually doing half of that. When you move over 2, you go down 2. When you move over 1, you go down a half. So I know right away that a is a half just by kind of counting it. Thanks, Norton, for telling me how safe my computer is. Go away. So I think I know that a is a half, but you know what? I can actually kind of check it with, I need this point anyway. This is my y-intercept, and this is my y-intercept is x is 0, y is 6. I can use that to make sure that my a is a half. So when I know that that y is 6, I know that x is 0. And let's see if this turns out to be a half for the a value. I think that's what it's going to be, but this will figure it out for sure. 6 minus 8 is negative 2. And yeah, divide both sides by 4, and a is negative a half. So yep, in vertex form, sorry, I wasn't fast enough to move the paper there, y is negative 1/2 x minus 2 squared plus 8. There we go. Now, standard form I can get from vertex form, and I actually do know that a little check that I'm doing it right is that I know that the c value should be 6. So let's see if that's what we get when we expand that. So y is equal to negative 1/2 times x minus 2 squared plus 8. Step 1, let's square that binomial. So that's x squared minus 4x plus 4. Don't forget plus 8. And then y is equal to, let's see, I'm going to distribute that, so that's negative 1/2 x squared. Negative a half times negative 4 is plus 2x, and negative a half times 4 is, again, negative 4, but don't forget the plus 8, and I said that this should be, oh, wait a minute, I said there should be a 6. Oh, that's because half of 4 is not 4, it's 2. Duh. Good thing I checked. Oh, half of 4 is 4. Yeesh. Sorry, I need a nap. So that's negative 1/2 x squared plus 2x plus 6. Standard form. Factored form is, of course, y equals sum a times x minus x1, x minus x2, and the a value, I already figured out the a value back in the other part, so I can just use it here again. And then I have x minus, now I can just read these off the graph, I think. So this is a x-intercept of 6, and this is an x-intercept, I could call it 6, 0 if you want, and this is an x-intercept of negative 2, and so that's x minus negative 2, which is plus 2, and x minus 6. If you want to, you can check to make sure that answer is right, because if you FOILed it out, it should be the same as that. And you can kind of see that it will be. That'll be x squared minus 4x minus 12. And if you times minus 12 by minus a half, you get 6. If you times minus 4 by minus a half, you get plus 2. I'm quite confident that those three answers are correct. And there we have it. Quadratic quiz. Your test will be pretty similar to what we just did.